Dr. Sheep here. Welcome back to our TGIF Talks, episode 152. I'm your host, Dr. Sheep, Joe my co-host, anonymous Phil.
Yes.
Okay, roll the intro. Please, Jesus Christ.
Did you see where it went?
Yeah, I see where it is.
Oh.
No.
Is this another one?
No, it's the same one.
That's what I thought. It was the
You're
same.
banned from touching things. Put it back.
Did you see what kind of like...
Oh, I saw. Oh, I saw everything. It's too bad they didn't see it.
We could let them.
No, stop. God, he's worse than a child. Anyways, how are you?
Fine. You?
How exciting. I'm alright.
You're alright? Good to hear.
There's a spider on my window outside.
Yeah?
See a little motherfucker? Need one of those salt guns. That'd be fun. Anyways, let's close Chrome so that it can update itself, although that defeats the purpose. Damn. Alright, I was gonna show you what I was talking about in Excel here. So,
yeah, it does look wonky.
well, I mean, yes, because I haven't gotten to fix it yet. But anyways, these are all the same, right to left.
Let me see.
But vertical, so if we look at
57.
57, okay. So if we go down here, I have this set to 18. And the bottom, set to,
You got 3 here.
set to 18.
And then this one.
Right, yeah. So 18 plus 18, what is 18?
36.
36.
Plus this middle one.
Hold on. Let's look at these. 22 plus 27. That's like, so we're over 100 pixels here. We're like 108, right? With this.
Let me see. Sorry.
Don't adjust anything.
28.
Please hit undo.
I didn't adjust it. It's still 28.
It says you did though.
What do you mean it says it did? It's still
Give me,
28.
give me the, no, it was 27 before.
It's 27.
Yes. Actually, there's an easier way of doing this. Here,
27.
give me this. Here, I'll show you, because I'll show you how I was adjusting it.
Can you just... Oops.
No, give me the mouse. I'll show you how to check. This tells, oh, this is in points. Ugh. It doesn't do you in pixels.
Alright.
Now you see my problem. Why the hell?
27. Plus 22. We'll get a calculator. We'll keep a running total.
Over here.
Where?
27 plus 22
should be
plus
49. 58.
I just did it. You no, please. I was gonna let me.
I can type faster than you can write.
What was the other one? 58?
50.
58. 107. That doesn't seem right, but that's because it's not. It should be 28.
It should be what?
It should be 28, not 27. Give me the mouse. Cause you touched something again. It is 27. Okay.
It was 20. It was 20, and you said no. It has to be.
Well, something's. Anyway, I thought it was 108. That's why 107 seems weird. Anyways, doesn't matter. Point is, we come down here, and we want to measure one of these motherfuckers.
18.
18. So if we do 18 plus another 18, because that's what the bottom one is. Why did it?
Let's check to make sure.
No, it is. I said it. Trust me. I was doing this for an hour. Plus, in the middle, it's different between each one.
Why is it not the same?
36. So plus 36 gets me 72. So 108 minus 50 was 52, right?
Yeah.
Sorry, 107. Damn it.
107.
Why did it not save over here?
It's right here. 107.
Oh, sorry. No, 72 is what we had.
What are you asking? 58. What are you talking about?
I don't know. Don't ask me where I got that number from.
35.
35. So
That's the
we
difference.
need to increase this by 35 pixels.
Yes.
So if we go into here, oh, I can't do that. Never mind.
We're at 36.
Shit. That's right. We need to 35 plus 36. That's 71.
Mm-hmm.
We need to go to 71 pixels. No, why is it? I can't.
There you go.
How much? 71?
Yeah. Right there.
That's not square. The pixels are different sizes. I wanted people to see this. Look at this. They're different sizes. Why are they different sizes? And the points are different sizes too. Why? Why? Excel. Why?
18. 36.
I spent 45 minutes trying to figure this out because it doesn't make sense. Here, give me this. I'll show you how stupid it gets too. Because if we go to Excel, a new Excel doc, how many? Okay, did it only open one? Thank God. It was opening like 8 earlier. Okay, so if we look at this one, it's in points. It's 20 pixels. So we want to make this one 20 pixels. Boom! It's a square.
Well, let's try that on yours.
It doesn't work. We just tried it. No, don't. No, you can't adjust any of these because it's all saved. Here, give me.
Well, I was just gonna adjust it and just experiment.
No, but I did. It doesn't work. It won't make a square, and I don't know why. The same. We did this. We did the math, and it doesn't work, and I don't understand why. If somebody in the comments knows why Excel is broken and how do I fix it, please explain, because it doesn't make any sense. Because I can't finish this until I fix the square issue. Because I can't stand up. Because I don't want to eyeball it. Because, if we make this poster sized, you're going to notice that. 1 or 2 pixels is a lot. When you blow it up to... And so I don't know what to do. I don't know. Is there a program I can just put things in and do this kind of thing in, or is Excel really the I shouldn't say the best way, the only way that I know how? I don't know what to do. This periodic table, I don't know, and it's Excel's fault. It's not even mine. I didn't do anything. It's just Excel is just glitched out, I guess. I don't know what the hell's the problem is.
Adjusted, so it's supposed to be 58. I don't know.
It doesn't make sense. Why do they have 2 different pixel sizes?
Have you tried asking Google?
But that doesn't. But see, they just say, "Oh, switch it to ruler mode, and then you can just measure it in inches, and you'll be fine." Well, I tried switching it to ruler mode. It just breaks things because it sets it as one standard page size. I tried it. It just breaks things. It breaks up the table and makes pages, and it's I don't want pages. I want this all on the same page. And I don't know how to adjust page sizes in Excel. Because I've never done that before. It's never been a problem.
This is 71.
I don't get it. I do not get it. It doesn't make sense. So if anybody knows how to fix this, so it's not stupid.
Just increase them all. Oh, it does.
No, yeah, but it makes them all equal.
Yeah, it does. I know. I see that.
Which I guess is okay. I don't, in some regards, but not in others. It's the reason why I have it set to that width, and I'll show you down here, is because of protactinium.
That's praseodymium.
Oh, so yeah, praseodymium. Because it's the longest element name. So everything is set to that, and then this width, this box, is set to which one of these was the longest. Which is like, I think, like tantalum here at 180.895. Because you have 3 digits and then like another 2. For the most precise.
I follow.
So, yeah. And then this side.
Do we really not know what these are?
These are, look at the element number.
No, do we not really not know that they're transition metals?
That's what this period. Ignore the coloring. I haven't fixed the coloring. I was just copying what my big periodic table says.
Oh.
I'm gonna change it. So that's actually, let's just exit out and just don't save.
It is interesting.
So let's talk about the coloring for a minute. I think I might want to make a video out of this. I think it's interesting enough. You know.
Mm-hmm.
So here's the thing, right? Let me grab that textbook again. Because I like and don't like that periodic table. I also grabbed the way things work. I wonder if it has a periodic table in it. Anyways, I actually, so we pull this up here, folks. Here, let me see the mouse. So if we pull up their periodic, I like some aspects of the periodic table that I want to adapt. And that is that it tells me what all the nonmetals are. So most periodic tables don't tell you what all the nonmetals are. They tell you these are the nonmetals, usually. And then they just label halogens, and this is their own thing.
Well, I've also seen a noble gas, diatomic nonmetals, metalloids. What were these?
The normal metals, ordinary metals, staircase metals, they go by many names.
But they have a more sciencey name.
They don't.
Yeah, they do.
No, they don't.
I've seen a periodic table that has a more... Is it monatomic metals? I've seen... They do.
Well, anyways, this doesn't even perfectly copy my big periodic table, because my big periodic table says these are part of the staircase metals. I don't agree with that. But I don't know. I have to do research. Maybe now in modern times we include that in there. I would look up other names for staircase metals. Anyways, but I do like how this book works, and that is it labels everything into 3 camps: nonmetals, metalloids, and metals. Which, truth be told, is an interesting way. And I think my periodic table will follow this to a point. Obviously, some of these we don't frickin' know. Like, hydrogen should be a white square.
Oh, post-transition metals.
Oh, yeah, there's another... that's the other name. I forgot that name.
Yeah, post-transition metals.
Yeah, that's the other name for it. So anyways, back to what I was saying. So I do like how this works. Now, granted, I will have hydrogen as white because and then maybe these would be gray to symbolize there's something else. I haven't figured that out yet. And then I think I was going to do outlines for other things.
Outlines.
Like you outline, like a colored outline.
Oh, for what?
So like noble gases will have a colored outline. Halogens will have a colored outline. Staircase metals, not staircase metals. The metalloids don't need one. And these won't need one. We always just call these non-metals. I mean, you can label them because these have different names. Because you have noble gases, halogens, the plasticines, plasticines, or something like that.
Yeah. Put like a blue border around it.
Well, no, that's what I'm saying. I'm going to do an outline. So, anyways, and then like over here, obviously, I'll outline these as well, and then I'll outline your rare earths.
Oh, so you want to keep just a simple color code?
I think so. Oh, and then obviously transition metals will have theirs. It won't be too simple of a color code because obviously these down here will be labeled.
But you won't have like many more than like 3 or 4 colors.
Yeah. And I think that's best. Well, and then of course I will tell you states of matter too.
Yeah.
States of matter will be labeled. I think that is the way to go because it will limit confusion.
How does it limit confusion?
I'm telling you what a metal is, what a non-metal is. Because like here, see, here's the annoying part with
what do you mean? You know these are non-metals. You know this is the dividing zone.
I know they're non-metals. But see, if you look at the noble gases, you don't know what those are.
You know it's a gas. You know it's not a solid. You know it's not a metal.
But is that a defining property of a metal? Because you can have a gaseous metal.
A metal can be a gas, but not at room temperature.
But what if 118 acts more like a metal?
Well, then you color it. Then you color it in a transition metal color.
That's what I'm saying.
Actually,
though,
no. It's probably more like a metalloid.
Well, yes, but it's still technically a noble gas. Therein lies the issue.
Yeah, see, we don't know, though. We don't know if it's a noble gas.
Right.
Because it will have 8 valence electrons.
Right. Which is why I'm saying that we do it my way. Instead of doing the way all these other places do it. Because they label they would label this as non-metals. But you need to also say that these are non-metals as well. You can't just say these are, and then these are just noble gases.
These are different. That's why I call them diatomic nonmetals.
But see, that doesn't work because now you have halogens. You're causing too much. There's too much. You can break this up into a million things. You could put these metals into their whole own thing, too.
What are those metals?
They're platinum group metals.
Platinum group?
Yeah,
you should. Ooh, yeah. See how many different dividing things you can
That's what I'm saying. You could cut this up a million different ways.
All right, fine. Then what if...
Which is why I like how simple this is, and then I can choose what outlines I want to do. I'm not limited to colors.
What if you had like 3 colors, like your red, blue, yellow, but then you have shades of yellow to represent like a golden yellow to represent...
See, my other problem with that was I want to make it so that colorblind people can look at it.
Oh.
Because if you're colorblind, you won't be able to tell the difference.
Yeah. Well, technically... Yeah, well, there's that and you'd confuse... But you can't have blue and red... Because like there's many types of colorblind. I think there's like blue-red, right? So like blue and red look like one color.
Yeah, right now, as this is, I'm pretty sure I have people that I work with that could not tell those 2 red shades apart, nor those 2 blues.
No, but I'm saying the blue and the red look the same color.
Well, yeah, but they also, like I said, they wouldn't be able to tell the difference between all 4 of those.
Yeah.
I have a coworker like that. She cannot see. It's horrible. She'll be like, "Oh yeah, this is this color," and I'm like, "Are you dumb?" And she's like, "What?" And I'm like, "I thought this was gray." I'm like, "Nope." She for the longest time.
You should show the.
We have tickets at work that we run things on. And a lot of them are labeled with pink for credit. Up until like a few months ago, she didn't know they were pink.
What was pink?
the credit slips were pink. She didn't know they were pink. She thought they were like gray.
Well, yeah, that's the color that most people compare it to is like a gray, because they don't. It's a whole new color to them.
Yeah.
But the color that seems most accurate to describe it as to non-colorblind people is like a gray or like a brown.
No, but I was telling, because she was like, we were doing something. I was like, oh yeah, you want to put the pink on top because that's the credit slip. She's like, pink? I'm like, yeah. She's like, this is pink? And I'm like, yeah, all these slips are pink. She's like, what?
Wait, did she never know
She didn't know they were pink.
No, but she knew she was colorblind, right?
Oh yeah, she knows she's colorblind. Oh, it comes up quite often.
Well, are dollar bills green?
I don't know. I've never asked her about the dollar bills. She probably, if you showed her a red and a 50,
a red and a 50. Yeah. Well, how much is that? How much is that?
If you showed her a 5 and a 50, she probably wouldn't be able to tell you the difference between those two. Probably the same.
Wait, are they different colors?
Yeah.
I've never painted. It's always just like a green, so I never like held them.
That's the old ones. The new ones are the 5 is supposed to be a purple. It's a very red purple.
The new 5s?
All the every 5 since like 2007.
Do I have a 5? No, I have a 20 and a 1.
The green ones. Actually, ones are supposed to be yellow. Oh, not yellow, white.
Yellow?
Sorry,
What?
they're supposed to be white. Sorry.
This is white?
That's supposed to be white.
It's like an off-white.
Well, yeah, they're all off the colors that they're supposed to be.
Off-white.
It's
not a true green.
Other than the 50s, sorry, other than the hundreds and tens, they're all off color. Because 100 is clearly blue, but somehow still looks green too. I don't know how, I don't know why, but 100 still feels green. Same with the 10 doesn't though. The 10 is just this ugly color. A horrendously ugly color.
Do this again. This is very interesting. I'm very intrigued by your issue. I'm sorry.
You're good. So
27.
that's I think outlines are the way to go. The outlines are going to be difficult.
Yeah.
Because the one problem with the outline is that like how many colors of outlines can you do? And like, do I need to do an outline for the my brain broke there. Alkali metals and alkaline metals, or can I just label as above them? Sorry, halogens and noble gases are the specific ones I would want to label. I would do outlines for the other ones. But I don't know. My other problem is I always like all the fun colors. And this kind of periodic table is jarring to look at with only 3 colors. But I've never seen it like this, and I kind of like it. It's not. They still fucked up. Oh yeah, they discovered one at 117. Wait, where's the other? The mass number of important radioactive isotope, not the atomic mass. Why is uranium number of an important radioactive isotope, not the atomic mass, is shown in the parentheses for these elements with no stable isotopes? Interesting. So bismuth should be should have parentheses as well. They just made praseodymium. Yeah, they just made praseodymium just like smaller. See this? All these other ones, most of these have the same size of text except praseodymium, promethium, and this.
Was it different?
Yeah, that's different. Praseodymium is clearly smaller than cerium.
Yeah, I suppose, yeah.
Oh, and they put lanthanum and actinium up there. But there's a lot of debate which of the N's Do the ends actually belong with the transition metals?
Mm-hmm.
I watched a whole video on it one time.
Yeah.
You still baffled by the pixel problem?
Yeah, it's interesting actually.
Yep.
Very interesting.
I don't know why. I don't know how.
Well, there's supposed to be what? 14? 1, 2, 3, 4, 5, 6,
Oh.
7, 8, 9, 10, 11, 12, 13, 14? Right? Because I think there's 14 orbitals in the in the, what is this, F block?
Yeah.
F block? I think it's 14.
But I always see lanthanum and actinium with them. I never see...
Yeah.
Lawrencium or lutetium. Lutetium. I never see them with transition metals, so it's like, I don't know. That's the debate, like,
oh, yeah.
right?
You know Lawrence. This was named after the guy from Oppenheimer who invented the cyclotron.
Oh, that's that freaking scientist's name. I couldn't remember. I can never. I always forgot his name.
He wanted to keep the whole Oppenheimer. He wanted to keep the whole Manhattan Project secret because he was part of that fascist group.
Fascist group.
Yeah. For like, what was it? Technicians, engineers, architects. Remember that? The whole Communist Party that he went to?
Lawrence wasn't in that.
No. Oppenheimer was, but he was keeping the project from Oppenheimer because he was in that.
Yes, it was communist, not fascist.
But it was like a fascist group, too.
No.
It was.
Okay, it might have turned into a fascist group, but it wasn't. It was supposed to just be communist, and communism obviously has problems. We all know. Actually, I brought my How Things Work out here because I was curious if this has a periodic table in it. I would feel like this would have something, but maybe this is more of a mechanical thing only. Whole gamma rays. Christ. Molecules. Is there not an index? I figured there'd be an index in a book like this. Ah, here we go. I want P. Painting, paper marking, parachute, parking meter, periscope, pendulum, photography. Periodic table is not on here. We have molecule. Well, that was like in the glossary or something. I figured moles, mechanical. Okay, I guess this makes sense. This isn't exactly a book. This is more of a God, this thick as a textbook. This is more... The way things work is more for mechanical things and less about non-mechanical things. Although it does have microcomputers in here, so that's not exactly mechanical.
Yeah.
Anyways. So... Yeah. The periodic table project is... It's on hold at the moment until I figure crap out. Which is annoying. Ugh. And then they're only called post-transition metals because they have p orbitals. Their electrons fill p's after d's, right?
Mm-hmm. Yeah, these are p orbitals.
I was trying to remember if they're p's or s's. It should be.
This is S group.
Yeah, that's what I thought. But anyways,
S, P, D, F. And supposedly there's a G.
A G?
Mm-hmm.
What?
Yeah, it starts at element 119.
Really?
No, I'm sorry. 121.
121.
So 119, 120, and then 121 will be like a new step down. It's a G orbital.
How do we know? Do we know that for a fact?
Yeah.
Or is that theory?
No, it's a theory of how it would work. Well, we don't know for sure because we haven't observed it, but it's a theory of how it would work.
Really?
You didn't know this?
No, I've never heard of G-orbitals before. And our periodic table is going to be completely broken if we discover element 121.
Yeah, I'm surprised you haven't heard about this.
It still has...
I think it's... Yeah. So basically it just makes new steps down. G block.
What?
You didn't know about this?
Wait, why are they putting F block with... Oh, that's right. There would be 3.
It's going to step down.
What in the fuck?
Yeah.
What the hell? Why are we showing this over here? What in the frickin'... What in the world?
Yeah, G block.
What the hell? I've never seen this before.
This is a whole new world for you.
This is brand new information.
Yeah. I'm telling. There's a wiki article on everything.
They'll never exist.
Yeah. Well, when we find the island of stability, when they last for seconds, then we might.
Oh, yeah, but that's the other issue, right? How are we... Because, like, the problem with proving G block is that those elements have to be stable enough so that we can do that.
Mm-hmm.
But, like, we don't even know how we'd make that. My God, look at that wide periodic table.
Yeah.
Wide.
It puts them all on a similar thing.
It's going to get so much worse.
That's how it is. It's staircase.
But... So actually, here's a thought I had. So is the periodic table for, like, all civilizations, do you think it would all pretty much look the same?
No. There's so many ways to organize it. That's another... there's a periodic table on organizing periodic...
Periodic table on organizing periodic...
Yes! What? You never heard about this? Let me go to Wiki. I'm telling you, you can find a lot of shit on Wikipedia about... just periodic tables. But there's a whole, like, art to organizing a periodic table. And there have been multiple different organizational methods proposed over the years that all have their merit. They all try to... It's kind of like map projections, right? You know, you have the Gall-Peters, you have the Mercator projection.
Right.
Then there was another one. There was triple or something. I don't know. Vsauce made a video on that too. Oh, here it is. Alternate periodic tables.
The hell is that?
Another way to organize it.
Here's
hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. You just keep going around and around and around and around.
Why?
It's another way. So...
Superactinized? Is that what they're calling G block?
Is that what they called it? Oh. Yeah. Superactinides.
Bruh. Bruh.
Theodore, let's see, they talk about him. I forget what his method was. But, here's the main article. It's just all about different ways of organizing the periodic table. And they all have different ways of things that they're trying to show. Oh yeah, here's this one for you. The optical illusion type thing.
What are they trying to show me here?
I know. Continuous two-dimensional periodic pyramid.
Look at that one. It's 3-dimensional.
Yeah. See, there's some cool little nifty ways to do this.
Looks like a pain in the ass.
I'm telling you, it's like an art. Art.
But why? Why do those other ones need to... So you telling me that an alien civilization may not choose their main periodic table to look like ours?
It is entirely possible. And honestly, I'd be shocked if they did make it look exactly like ours. Just because there's so many different ways to view it.
I suppose. But I mean, they'll still have the same. But I mean, everything will still be broken down the same way, though.
Probably. I mean, yeah. If they have a way to look at elements, they'll come to the conclusion that these are the simplest forms of matter. These are the.
I don't think you could build a. I don't think you could travel the stars without being able to do this.
Just throw some hunks of metal together.
What?
Connect some wires. Boop, 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 boop.
Bring the rock from this quarry. We need that rock. Don't know what's in that rock. Don't know what makes it good, but a good rock.
Yeah.
No way you can build an advanced civilization with that.
What does an advanced civilization really need to know all this sciencey stuff?
What do you mean, this is science stuff? Of course it does.
Why?
What do you mean, why?
A carpenter doesn't need to know about all the intricacies of his wood. He can feel it. He can feel his wood and be like, this is good for a house.
That's wood. Wood is inconsistent. This is the periodic table. This is filled with this.
Did our ancients need to know all about the different types of metal they were working? They're like, don't use that rock. That rock's bad for spears.
They did know. They named the metals.
No, but they didn't. No, some of them were compounds. They didn't realize they could be broken down further. There are alloys.
But we made like brass and bronze. We made those.
Yes,
those were intentional.
But we didn't know about all the chemistry about how many electron orbitals they had.
Yeah, but we knew tin was as basic and copper was basic. We had a good idea that those.
Yeah, so we didn't know all the specifics about how many protons and electrons it had. They didn't care.
I think that would be important, especially if you're going to have to build advanced materials that can withstand,
I think they just started experimenting and just start combining stuff. And then somebody along the way was like, we should categorize all this.
I'm telling you.
I don't think it's necessary.
Where is G block? It says G. Oh my God, G block is so stupid.
They haven't added it yet.
How do you calculate that there's another electron orbital like that? How do you figure that out?
What do you mean? It just seems why does it have to end here? Look at the periodic table. Why does it have to end here? Why not just put another one? Why not have another one? What if it just keeps on going down and then it just keeps having more staircases? Each two less than the other.
I mean, at some point, these atoms are going to be so freaking big, you can see them with a microscope.
So, why not just keep having it go down, down,
I
down?
asked my teacher one time, do you think we could make an atom big enough to see in a microscope? And she just went like...
We actually have pictures of atoms, though.
Yes, I know.
We have taken an actual photo.
With electrons.
What? No. We have...
You can't use visible light to take a photo of an atom.
First photo. Graph. I guess that'll work too. Photograph. And then atom. Yes.
Photograph is...
Photograph of a single strontium atom wins Natural Science Prize.
Yeah, but they didn't use visible light.
Damn it, I don't want to.
Welcome to National Geographic, where you have to pay. And
I closed it. Photograph atom. Science American. Oh, well, no, that's not the image.
Ha!
Do you have to pay for all these stories? Oxford, can I read your article?
Nope. Oh,
yes.
Yeah, but you can't see the image.
It's right here.
I don't see the atom. That white dot?
Yeah, right there. You see it?
This wasn't done with visible light, though, was it?
I think it was. It looks like visible light.
How they get? Why does it
They
look so
held a
much?
single. You didn't hear about this? This was like all
No.
over the news. I
No.
guess many years ago, but still. Image of a single strontium atom held motionless by electric fields won an overall prize. It was in an ion trap. Laser of blue light. When illuminated by a laser of red, blue, violet color, the atom absorbed and re-emits the light.
Oh, we're not. That's
the
why it
energy
looks
trap-
so big. I was gonna say, why does that look so big?
What do you mean? It's super tiny. They're zoomed in. They're zoomed in a lot.
Look at those wires.
They are zoomed in.
No,
These
but you
are like
couldn't
nanometer
be.
thickness.
But you no, it can't be because light's only so big. Because you have the problem is the size of your light.
They zoomed in.
You can't zoom in.
They did. They zoomed in.
There's a reason microscopes can only zoom in so much. It's because they literally get so small.
Yes, I know. But I'm telling you, we have a photograph.
You have a photograph of the emission of an atom.
Yes.
Yes, the atom is there, but you're looking at the emission, not the actual. You're not taking a photo of the actual protons and neutrons.
Well, the light. You're sending light to get light back. A camera just opened up an aperture and lets light in. This way, you're sending in light and you're getting
capturing
the light
the light the atom made. You're not.
Yes.
It's different.
So there was an atom there.
But you're not reflecting light off of it.
Yeah, reflection, emission, potato, plutonium.
No. Yes, potato plutonium is correct. Two different things.
Yeah.
I was gonna say you can't take an now. Let's see. I see the discrepancies here. Losers is what I call them.
Single atom is visible to naked eye in stunning photo.
Anyways.
No, you haven't seen this picture before.
Nope.
Yeah, no, I will say, electron microscopes are pretty cool. But no, this is not an electron microscope.
Electron microscope's the proper way to look at an atom. It's a probability curve. A three-dimensional probability curve.
Yeah, but this is pretty cool, though, right? It looks like... It's a picture. It's a photo.
Of a white dot. You know, I've got a lot of photos of white dots.
Yeah, me too. Photos of white dots, rocks, pictures on rocks.
Lots of rocks.
And sand.
Lots of sand and rocks.
Oh, don't forget about logs.
Logs that
Freaking
were
logs.
rocks. Logs that are rocks.
Logs that have turned into rocks.
Sand is just rocks. You realize all you've
Guys,
taken
all
are
we
just
took
rocks.
was pictures of rocks. We took pictures of rocks. Houses made out of rocks. Houses made with rocks with pictures on the rocks. We took pictures of tiny rocks.
Yeah, you want to go to Petroglyph National Monument. More pictures on rocks.
More pictures on rocks. Trees that have turned into rocks.
We have lots of that. So many rocks.
Isn't it wonderful?
Absolutely. Luckily, California.
We took pictures of white dots that probably have rocks orbiting around them.
Actually, guaranteed. One of those photos has pictures of stars with rocks orbiting them.
Yeah. How many stars don't have
I
planets?
think it's like a 50-50 split.
Is it really?
Maybe
A
less.
star that just is there with no...
I think it's more likely that there is a planet than there isn't a planet. I think that's the probability. I don't know what the actual probability is. You can Google it. You have Google right in front of you. She's just waiting for you to type in some information to her.
Oh, here's a photograph of a hydrogen atom. This is what you were thinking, right?
Yep.
This is what you were thinking. I seen this one too. I think this is a carbon atom.
Looks like a flower.
Yeah.
What a loser. Anyways. Are we going to Google the stars or are we just going to ignore this?
What did you want to Google? Stars?
You were going to... What percentage of stars are planets? I thought you wanted to know.
All right. What percentage of stars are planets?
What?
Is that what you said?
No! What
did
the
you-
hell? Oh my god.
Well, we found this.
Yeah, but now we gotta read. We could have gotten the answer in 2 seconds. It was literally one of the options and you ignored it.
What percentage of stars have
It's right there. Just click on it. This is painful to watch sometimes, kids.
And then I click on it.
20% of sunlight. That doesn't answer the question. Oh. I wanted all stars.
20% of sun-like stars have at least one giant planet. Giant-ass planet.
I don't want the breakdown. I want just what... If we take all the stars in the known universe, what percentage? I guess we don't know, because the higher energy stars, we can't...
What is the percentage of stars with planetary systems? Here
Oh my god, we're on Quora.
This is not Quora. This is a stock exchange.
Yeah, that's even worse.
I think it's more reliable than Quora.
This is like asking the wind what 2 plus 2 is. And hoping to God it spits out an answer, when in fact it won't.
Purpose of the drink. Best estimate, 22%. God damn it. This is the same. You know what? We'll just say 20%.
20%.
1 in 5 chance.
1 in 5 chance.
You get a picture of the Orion constellation. Guaranteed, there's a planet orbiting one of those stars.
Yep.
Could be Betelgeuse.
I doubt it.
It could be.
Actually, I doubt any of the Orion ones have stars.
What do you mean? There's 5 stars there. You're telling me the probability is wrong?
No, I'm saying those are all giant stars.
So?
You mean so?
You don't think there's one giant star out there?
Giant stars don't... Well, that's the problem, right?
It could have like a protoplanet, like a little bit of dust that's kind of like...
That's not a planet. That's a protoplanet. You literally just said...
It has planet in the name.
Dust. It's dust. You took a picture of dust.
If Pluto can be a planet, a protoplanet.
It's not a planet.
In my book it is. It's a wannabe planet. It still has planet in the name.
Okay. Anyways. Christ. No. But the, I'm sure. That's the large stars. That's the problem, right? Looking for, planets around them takes time.
Yeah.
Lots of time. Because think about how long it takes for the Earth to go around the sun. And that's
about roughly a year. Just about.
Yes.
Pretty close to a year.
Yes. That's not the unit you should use.
What, about a year?
No, that's when you say 1/10 of a decade, and you're just like, nope, still not the unit to use. 1/100th of a century?
Yes.
Nope. 1,000th of a millennium?
I'm gonna use that. Nope. Now. I'll take the. Not only does it take the Earth to go around the sun, about 1/10 of a decade.
They're gonna look at you like,
what?
That's not the unit of measurement.
0.1 decades. 0.1 decades. Oh, I found a new unit. I found a new way to represent something. You know how many stars are in the universe?
About 2 moles.
No, a third of a mole.
Really?
A third of a mole. Yeah.
Oh, that was atoms in the universe. Was 2
No, that's 10 to the 80.
Yeah, it was 2 moles or something.
Hellimoles?
Yeah.
I've never heard that unit. Hellimole?
Well,
did I share that with you?
No. I heard it somewhere.
A hellimole?
I swear to God, they said hellimole, and I went, what?
Because that's 10
the mass,
to the,
yeah.
That hella is 10 to the 24 plus 10 to the 20. That's 47 now.
You got to remember you're doing
you add exponents when they're multiplied.
Yeah.
Yes. So 24 plus 23.
And what do you get?
45.
Well,
47.
Which is about, and 10 to the 80 is, about, you add those together.
What?
You do two of those together.
No, that's not what that means. You were talking about two different things. You're saying 2 hella mole.
Yeah.
This is
multiple.
24. This is 10 to the 23. So what you're left with is 2 times 10 to the 47. The atoms in the universe is 1 times 10 to the 80.
Yeah, they said there was about 2 hellimoles. Whatever the... How do you...
2 times 10 to the 47. That's not... That's
okay, well, okay. I don't know what the hell they were talking. I swear to God, somebody said hella, and there were 2 of them, and they were describing atoms in the universe. I don't know where the fuck I heard it. I don't know where the hell I saw it, but I swear to God, that's what they said. But they might have said something else too. It might have been like, I don't know. I don't know where the fuck I heard it. I don't know where it wasn't in an article. It was in a YouTube video, but I don't know what fucking YouTube video it would have been. Or no, it was in a short.
Of course it was in a short.
Or I don't fucking remember. Maybe I dreamt it. I don't fucking know.
You probably dreamt it. 2 hellimoles.
That would make sense.
Because it sounds just completely obscure. Something like that I would say. That's what I'm saying. This is something I would say.
You didn't say it, though.
I know. Well, it happened in a dream.
Probably. I don't know. I don't know where that came into... I don't know why somebody said...
Because I say things like megadeciliters.
Megadeciliters?
Yeah.
What is that? You're describing the amount of water in a lake?
Yeah. Megadeciliters. Actually, no, that quote actually came from Dune. Have you seen the movie Dune?
No.
Oh.
Megadeciliters.
Yeah, they're like, there's like 10 megadeciliters. I was like, what?
Why?
It cracked me up. I started.
Why? So it's 10 liters.
It's something like that, yeah. They combined 2 units on like the opposite side. I was like, what are they doing?
Wait, oh, Dessa. They didn't say Deca.
No, yeah, Deci.
Fuck.
2 megadeciliters.
So you just lob off 2 decimal points from mega, right? Is that what we're saying?
No, 1. Deci's 1.
Right.
Deci, centi, milli.
Right. So you lob off
1. So 10 to the 5.
So it's
10 to the 5 liters.
You could have just said 100. You could have said 10 kilo.
10,000.
10 kiloliters.
Yeah, that's too much.
What do you mean that's too much?
No, it'd be 100. Because it was originally 10. 10 megadeciliters.
So it's 1 mega. So it's just 1 megaliter. I'm gonna kill myself. I'm gonna.
They said something. They said something funny like that. But yeah,
it's just 1 megaliter.
It was from the movie Dune.
1 megaliter.
Yeah.
Which
it was great.
Who the fuck measures something in megaliters? How many liters of water are there in the ocean?
I don't know. That is interesting. See, this is how I get like 50 Chrome tabs open.
And luckily, we have 64 gigs of RAM, so it should be all right.
Liters of water. .36 sextillion.
Okay, never mind. That's not going to get anywhere close to mega.
I don't actually know what the exponent units are of sextillion.
Neither do I.
Billion, trillion. So 9 plus 12.
Great.
Is that 21?
Yes.
Anyways. Did I close the wrong one again?
No, you didn't close anything. Yep. Now you closed them all.
Which one was it again?
Well, no, we don't need to. We don't need
that
to.
I had opened originally. This one. How many atoms are there in the universe?
But why did you pull this back up?
Number of atoms in a mole. I want to try to see if I could look up 2 hellimoles.
I probably dreamt it.
I know. I was seeing if typing it into Google would yield anything.
It did not. No, so what is... No, back to what I was...
It sounds like something...
Back to our this deciliters bullshit.
Oh.
How many megaliters are in a sextillion liters?
The sextillion, 10 to the 21, I think. My fingers are not. No, it's not. Yeah, 10 to the 21.
Okay. So, what's mega? 10 to the...
10 to the 6. 6, 12, 18, 3 and a half.
Mega liters.
3.5, yeah.
The world's ocean. What? Okay, how many sextillions?
Oh, no, I'm sorry. 3.5 times. So, what is that, 9 billion?
9 billion megaliters.
No. A billion. Not 9 is the exponent. A billion. There is a billion megaliters in
1
sextillion. 1 sextillion. Yeah.
Fucking Christ. What is this? What is this bullshit? Alright.
You know
What's that?
I really wish we would use long notation, because it would make this so much easier. Back in the day, when they were making these numbers, sex meant 6. So 6 billion meant 6 million. So if you took the exponent, if you took a million, which is 10 to the 2, right?
What?
No, 10 to the 6. I'm sorry.
It's like 10 to the 2? I'm like, that's 100, sir.
It had 2 groups of 3. Hang on.
10 to the fucking 2. That's 100, sir.
No. Let me talk.
She's like, that's just 100, sir.
Let me talk. It had 2 groups of 3. That's what I meant to say. 2 groups of 3.
Okay.
Now, 6 millions put together.
Fuck.
So
That's even bigger.
So you just take 6 times 6, so 36.
That's
No,
even.
I'm sorry. Or did you add them? No, you added them. So 12. Right?
No.
12 zeros.
You multiply.
You did have to multiply. So it'd be 36.
Yeah, it gets really big, really fucking fast.
Yeah, so they use thousands. Yeah. Because how it used to be, and then I think it was the French that changed it. In like the 17 or 1800s.
You're telling me that when I counted past a million,
so you had a million, because it used to go
1,000 million.
It used to be a million. Billion was billion. So it was 2 groups of a million. So 12 zeros. So a trillion used to be called a billion. And then a trillion.
So when hold on. So when you counted, you got to 999,999,999. The next number was 1,000 million.
Yeah. Well, and so what they did is they created another number for 1,000 millions. I think it's called a millard.
A millard?
Yeah, a millard.
This sounds more convoluted than the one we have now.
Millard. Yeah, a millard. 1,000 million.
This sounds more convoluted than just doing
a millard.
A billion.
No, because then a billion is what a trillion is. Because it would be 2 millions stuck together. So then sextillion is 6 millions stuck together.
Okay, it makes sense
for
the naming scheme.
What?
It makes sense for the naming scheme.
Yeah.
But it doesn't. But now you had to make up
so
a
then
fucking
a trillion
number.
is 6, 12, 18 zeros stuck together.
So did we not fucking put... So they put periods between...
I forget how they notated it.
Because I feel like you'd go 6 fucking places before you put a period.
But the thing is, numbers, they had no reason to call numbers that big, you know. After a trillion, it's like, bro, what are you ever going to use that number for? Counting grass?
Yeah, after a millard, they didn't have a reason to go any higher.
Exactly. So you pretty much stopped at a trillion. And then, I think it was the French that changed it and was like, you know, what if it's counted by thousands? You know, every 1,000 we give a new number. So million, billion, trillion, quadrillion, quintillion, sextillion. So all the numbers just offset by 1,000. So you chopped off 3 zeros.
I think they go by a completely different... Once you get
so now it makes no sense. Billion no longer means 2 million.
Oh, just wait till you get to 20.
20.
And it just switches to vegetarian.
Oh, yeah.
And it's just like, the fuck is this?
Yeah. That is a thing.
I know, because I play Egg Inc. And you get into the vegetarians of eggs. And you're like, what is this?
10 to the 20, right?
No.
What is it?
I'm pretty sure it's 10 to the 2020.
10 to the 2020.
No, sorry, it'd be 10 to the 3 to the 20.
Vegetillion?
Yep, that's right.
1,000 November de Sicilian.
The fuck?
What is this as an extra?
Oh yeah.
One was
No, yeah, Novemicillion. Yeah, non-decimillion. Yep. Yep. You've never played A Ink before, have you?
10 to the 63.
This is a normal thing, sir.
10 to the 63. Well, at least 63 is divisible by 3, so it works.
Because teens are the decillions.
Yeah. Oh, here, look, Millard.
Fucking Millard.
Millard.
Sounds like that your dad is a number now.
Billion, trillion.
I love how they give up after vegetillion. And it just goes all the way to 100. Google. What?
Oh, this is what I thought you were saying.
Yeah.
20. Oh, that's why I thought it was 10 to the 20. Because it's 20. There's a 20 there.
Yeah.
Yeah, see, longhand would be 10 to the 120.
Fuck. Look at the one below it. Look at centillion.
Centillion. What'd you say? Sagittalian?
No, I said I don't know what the fuck I said.
Centillion.
Centillion. 10 to the 600?
And 3.
No, it's just 600.
Oh, I'm sorry. 303.
Why would you ever need that?
I don't know. When do we use this number? I want to know when we use this number.
That's Google, right? Well, no, it's 3 to the 3. Never mind. What do we use that number for?
Number.
What does that represent?
Represents 1 followed by 303 zeros.
But what is the use of that number?
Is there a centillion anything? Let's pause for a moment.
They're just talking about the fucking number. I don't care.
This is what you get from Cora.
Just a bunch of bullshit.
You're born infinitely unique.
Great.
It's raining, it's pouring, the old man is snoring, is a warning.
Oh, is it a probability?
I don't know. Mole conversion.
Moles? What you...
Well,
How? There aren't enough atoms in the universe.
I don't know.
There aren't enough atoms in the universe to represent that.
It probably is a probability. There's probably something that has that high.
The 1 in centillion chance of happening.
That's probably how many chess games there are.
Yeah, isn't that wild?
There's a lot.
Can we talk about how
many chess games there are?
We can make numbers so big that we can make, if we wanted to count out every piece of a number, we would run out of... I just thought of a number.
What?
You take every atom in the universe, it represents a bit of information, right? And so we can calculate, and then we can calculate the maximum number we can hold with that bit.
Yeah.
So, like, in one
10
atom, what can
80.
we... No. Each atom... Let's say an atom can represent... or, like, 3 atoms can represent 100 or something. I don't know how you would do... Somehow it would represent,
there is a YouTube video you need to watch. My friend showed it to me last Friday.
So you could make a number with that. That's the fun part about the big numbers. You can make up a fucking number and name it. I've probably seen it.
Yes, this one. We need to watch this.
Beyond Infinity number comparison.
Yeah. We need to watch this when we're done. It's only 7 minutes.
Oh, good, because we have an 18-minute video over here for cursed units.
I'm telling you, it's a good watch, though.
Okay. Well, anyways, what a podcast we just did. We went from talking about the periodic table to large numbers.
Yeah.
I don't know how that happens. I don't know why it happened. I didn't think it was possible.
You brought up 2 hellimoles. That's how it started.
Yeah, but where did the 2 hellimoles come from?
What were we talking about before that?
Oh, we were taking a picture of an atom. And then we were bringing up fucking stars, and I think.
Yeah.
Okay, yeah, that's what happened. Anyways, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New podcasts.
And I brought up 10 megadeciliters.
Next week is the last podcast for 2 weeks. We will be on vacation. And good night.